Hey, it's Matt with Replit here, and if you're trying to deploy an application, you're in the right place because today we're going to talk about the 4 different types of deployments that we have on Replit. And we're going to go over each type in detail. We're going to talk about what apps make the most sense for each type. And then in cases where you could go either way, specifically with reserved VMs or autoscale deployments, we're going to discuss the pros and cons of each approach. And maybe there are some things you could do to deploy your applications with one, but it might not make sense. So we're going to go over all of that. First, I'm going to walk through the 4 different types, and then I'm going to present a decision tree, which you'll be able to find in the comments, in the links below. That's exactly the same logic I would use when I'm trying to figure out how to deploy my application. So my goal is that by the end of this video, you're pretty confident about how you deploy any project that you're cooking up. And I'll link to some other tutorials that might help you with more complex deployments. But let's jump right into it. So our first type of deployment is a static deployment, and the name is pretty self-descriptive. Static deployments are called static because they compile to a set of static files. Often these are HTML or JavaScript files. But when I say static, I just mean they're being run by the client. They're being executed by your browser. And browsers most commonly serve HTML files and execute JavaScript files. Now, for example, something like running Streamlit is not an example of a static file because in order to serve a Python application like Streamlit, you have to run streamlit main.py. So you're actively running a command against Python, which is not live in the browser. Now, you'd be very surprised the different types of things that you actually can run in the browser because browsers support running JavaScript client-side. For example, some really cool demos with Three.js. I've shared similar demos. Some really cool new projects from the Transformers.js library, which involve running LLMs client-side, are all becoming more possible. So don't kind of like throw shade at static deployments for not, having a client component. But what a static deployment is a set of precompiled static files. The thing about that is that they're very fast to deploy. You can deploy them in quite literally seconds on Replit. And if you're looking for a parallel here, maybe you're still trying to bridge the gap as to what a static deployment is, think GitHub Pages. If you can deploy it on GitHub Pages, you also can deploy it as a static deployment on Replit. Our requirements for static deployments are a public directory and a build command. The public directory is where the output of the build command goes. So I think for frameworks like Vite, that's dist. For some under the frameworks, it might be build. It's just basically if you run like npm run build, what's the directory that those static files get output to? And then the build command follows from that, right? npm run build would be your build command if you're building to that directory. So pretty straightforward. Static deployments are really great. My blog is deployed as a static deployment, but they only serve a limited set of deployments. If you have a server, if you have something that's actively running a framework, this is not the deployment for you. But we're going to go on to our next deployment, which is also pretty simple, pretty straightforward, and those are scheduled deployments. Scheduled deployments, as the name would suggest, are scripts that run on a schedule. And these could be great for fetching, scraping, updating data. They could be great for any number of things that you need executed, maybe sending a message to a Slack channel or performing an action on a set cadence. And the great part about scheduled deployments is that they're going to execute once and then they'll be off. So if you think about how much compute you're using, it's likely lower than if you just ran something constantly. Because scheduled deployments are executed and then shut down, they don't really have a UI. The UI wouldn't be available for the user. So if you need a scheduled job as a part of some larger application, you might think about multiple deployments or folding that scheduled job into another type of deployment. Now, if you're familiar, you can think about a scheduled deployment like a cron job. We actually use the cron syntax when defining the scheduled deployment. If you're not familiar with that, don't worry, because we compile natural language to that syntax. We make it really easy for you to define exactly how often you want the thing to run, or define cron syntax because you know what that is. So requirements for a scheduled deployment, we have a build command, completely optional. We have a run command. For example, if you wrote a Python script that went out and fetched data and it was in main.py, your run command would be python main.py. And then we have a timeout. For example, if you're doing some kind of fancy script that doesn't necessarily work every time, or you want to be terminated after a certain number of minutes, or a certain number of seconds, you could provide an optional timeout. But really, all you need for this one is a run command. It's pretty straightforward. You're just running a script. So now we're getting into the two more complex type of deployments, or I would call them complex because it's easy to mix them up. But the first of which is reserved VMs. And a reserved VM stands for reserved virtual machine. Again, the name is very descriptive here, is just an always on sort of machine that's running in the background that you deploy your app to. So if I had Python, main.py, and I wanted it to run continuously, I deploy it to a reserved VM. It's going to run and execute Python main.py, and it's going to keep that command alive until I tell it not to. So in a reserved VM, the machine is always on. What that means is that because the machine has the same size, you're defining the size of the machine when you deploy, and it's always on, you're going to have a fixed cost. It's going to cost a certain amount of money every month. You know exactly what that is. It's not going to change. Now, there are downsides to that, right? If you define a certain number of resources and say, your app blows up, or you build an API and deploy it, and the API blows up, or it's doing something really hard and you didn't define enough resources, your users are probably going to experience degraded performance. It's not going to be good. So you have to be careful when you're allocating resources to be sure that you're giving your reserved VM enough to execute on the jobs that you want it to. The requirements for a reserved VM are a optional build type, a run command. You need the run command, an app type. So you're either defining a web server or a background worker. That just determines if your app has an exposed front end. For example, if you wanted to deploy, say, a Discord bot or a Slack bot, those would be background workers because they don't have a UI. They're actually really good choices for reserved VMs because if you think about most of those bots, they need to listen constantly. If a user was to put a / command in Slack or put a command in Discord, and that command is going to ping, your server, and then the server is going to do something and it's going to respond to the command. And those servers need to be always on. They need to be listening for those commands. So reserved VMs are really great for that. Oftentimes, the types of computations or work that you're doing for those bots isn't super intensive. Now, right, you could also deploy, if your Slack bot is not responsive to the user and it's just sending a message, every 20 minutes, every day, that could be a scheduled deployment as well. It would be cheaper that way. But if you need something that's always on, you want to go with a reserved VM. And finally, a port configuration. This is mostly optional because if your app runs in Replit, we're going to configure the port for you. So you don't really need to worry about that unless you're running into problems deploying the app or you haven't actually run the app in Replit or configured the port. But assuming that you set everything up correctly, this shouldn't really be required. So this brings me to our final type of deployment, autoscale deployments. Autoscale deployments are scaling servers. They can scale up or down to accommodate varying amounts of traffic for your application. So think about it like if you post something on Twitter, maybe you build an app and you're trying it out. You don't know if anybody's going to use it and you just put it on X, the platform formerly known as Twitter. And it goes viral and 1 million people are coming to view it. If you configure autoscale deployments properly, you can scale up the number of machines automatically as people come to your site. And if you select the proper machine resources, this is kind of like a trial and error logic thing based on what your app does, right? But if you configure the resources properly, there shouldn't really be any interruption as all these people come to your application because we're going to spawn multiple instances and scale this application up to accommodate all those people. So autoscale deployments are really powerful that way. And the flip side to that is that if nobody views your application, that's most stuff I post on X, honestly, right? If I don't need to be worried about anything going viral, I need to be worried about posting all this stuff and then getting billed for it because nobody views it and it's running all the time. Like if I spawned a bunch of reserved VMs, they're always on, they're running all the time. But with autoscale deployments, if nobody looks at your application, it's going to scale down to 0, which means that it just kind of shuts off. It's kind of in sleep mode. If you think about your laptop goes to sleep, your deployment goes to sleep. What that means is that if nobody's looking at your application and then one person comes to see your application, there might be a small amount of time where it has to wake up, very much like a computer waking up. But often it's 1 or 2 seconds, it's unnoticeable, and then it's going to stay warm for quite some time while other people use the application. That's really great because it means I'm not getting billed when it's asleep. And that's great for, like cost purposes. There are some pros and cons to that. We're going to talk about those a little bit later in the video. For an autoscale deployment, you optionally need a build command, you need a run command, obviously, and you need a port configuration. Again, the port configuration is likely already set. Also note that there are many more configuration options for the type of machine when you're deploying via Autoscale, because you can pick the maximum number of machines that we scale horizontally. For example, you could scale 1 machine, or you could scale 5, as well as the actual power for each machine that's being spawned. So pay attention to that when you're building your application. That's largely dependent on what your app is doing. So I'll leave that to you. Now, one additional thing before we dive into my decision tree, I want to talk a bit about autoscale versus reserved deployments, because this is something that's confusing. It was confusing to me when I first learned about the concept. So I want to try and break it down. If you're saying, hey, I know this thing isn't static, I know it's not a scheduled deployment, it should probably be autoscale or reserved, I just really don't know which one. Hopefully the sort of cost certainty and wake up explanation can help you decide that. But if not, I'm going to break it down a little bit more. So again, autoscale deployments are really for scaling servers, and they have a variable cost, right? But reserved deployments are always on. They could be like a web server or background worker, and they're going to have a fixed cost. So you get cost certainty with those. We're going to talk a bit more in depth, like technically, about what that looks like. But the analogy I like to use here is a Nest thermostat or a greenhouse, right? If you have an apartment, I'm in an apartment now. What a coincidence. You probably want a smart thermostat, because your smart thermostat is going to keep the apartment cool when you're there, or keep it warm when you're there. And then when you leave, it's going to save energy. And that saves you money, especially in California. Energy prices are crazy here. What's the deal? Anyway, your smart thermostat is going to be intelligent and save you money. That means that when nobody is using the space, you're saving money. When people are using it, you're spending money, but that's the whole point, right? To be comfortable. If I had 40 people in here, this assumes I have friends. For the sake of this video, let's just assume I have some friends. If I had 40 people in here, if I managed to convince 40 people to spend time with me, this apartment would probably get pretty warm, and my Nest thermostat would sort of kick into gear and cool the apartment down. That's like an autoscaling deployment. As more people come in, you're going to kick up those servers. They're going to spin up multiple instances, and the workload shouldn't be interrupted at all. And so in that sense, it's really great. Now, Matt, you're probably saying, okay, well, that sounds perfect. Why the heck would I ever want the alternative, a reserved VM? Well, I also have plants in here. You might not be able to see them in the frame. This is one such plant. Those plants, if you think about the optimal way to grow plants, you don't want the temperature to be going all over the place, right? You want the temperature to be stable. And that's the whole concept of a greenhouse. So for other things, you want a constant temperature. For example, you have a Slack bot or a Discord bot. It just needs to be running all the time. You don't want it to scale down to 0, because it's actually watching for some message. Similarly, if you had an API, right? The whole idea behind an API, an application programming interface, is that at any time, someone could call that API. Maybe you have another application that's calling the API. Maybe you're using something like Next.js, which has both client and server-side code. Next.js uses APIs. If you dig into App Router and things like that, those APIs have to be running all the time. Otherwise, the client might try to call the API, and if it's autoscale deployment, it starts to spin up from 0, and then there's some latency there, right? And that's a non-optimal experience. So the analogy I like to use here, autoscale deployments, kind of like a Nest thermostat. They're going to keep you cool even if there's a lot of stuff going on. Sometimes you need a constant temperature. Reserve VMs, more like a greenhouse. Okay, that's my nerdy analogy that I just really love for some reason. We're going to get into a decision tree. If you're still watching this video, I assume you have more questions. So this will cover basically every scenario I could come up with when you're trying to deploy. Okay, so here's my decision tree. This is how I think about building on Replit. We're going to start with the simpler solutions first, then we're going to dig into the more complex stuff. You're deploying an app or website. Yeah? Actually, no, I'm not deploying an app or a website. What am I doing though? I am building an API. If you're building an API, just deploy a reserved VM. It's always on. People will be able to access your API. You just need to define the parameters. You'd want to use a reserved VM and not an autoscale deployment because of that cold start problem I described earlier, where if nobody's using your API, it's going to shut off. And you don't want that. If you're deploying an API, if you're deploying a bot, I would put bots under the category of an API or other type of infra like that has to listen for some event. Reserve VM. Easy answer. Also not. I'm running a script. We talked about this. Scheduled jobs. If you're running a script, it's not a bot, it's not a website. You just want to run something on a cadence. It doesn't need to be running all the time. It doesn't have to accept user input. It just needs to run every day at a certain time. You deploy a scheduled job. Okay, let's get to the more interesting part of this decision tree. You're deploying an app or a website. Yeah? Yeah. All right, cool. Let's start on the right here. My app needs a server or program that's running continuously. For example, if I ran something like Python main.py or Streamlit main.py or you're running, like Next, something's being continuously run. Now there are a couple options here, right? This is kind of what I was talking about earlier. We did the autoscale versus reserved type deal. Same thing here. You could deploy this thing as the autoscale deployment. You could deploy it as a reserve deployment. There's another solution we're going to talk about in a little bit as well. So first option, I want to be able to scale up quickly to handle large amounts of requests. And I'm okay with variable cost and minimal warm-up time. You might already know what I'm referring to here. So that's one option. The other sort of option is my app needs to be running constantly with access to consistent resources. I want cost certainty. Okay, we're going to assume my hypothetical app is on the left. And if it's on the left, and if it meets these criteria, maybe it's a server, it's using HTTP, HTTP2, WebSockets or gRPC, or I want to try out multiple ideas without spending too much. This is kind of like the X example that I mentioned, right? I could post 100,000 apps. If nobody uses any of them, I'm not getting billed for them. Then we'd want autoscale deployments. Cool. Now flip that over to the other sort of option here. Maybe I want a wrong lane connection. I want to deploy a bot. I want to run a background activity outside of request handling. Okay, so in addition to just handling the user's requests, I want to be running something in the background. I want this thing to be constantly doing something. My app is not a server. My app does not tolerate being restarted easily. One of the things about autoscale deployments is that if it scales down to 0, your app's going to restart. And this gets us into like persistent data within REPLs. The REPL storage is not persistent. It's actually a snapshot of your application when you click deploy. So think of all the files and directories in your app. When you click deploy, that's snapshotted and deployed. If you have like a SQLite database in there, SQLite database is not going to persist. That's why you'd need to use persistent data in the form of a Postgres database we have options for, a key value database we have options for, or object storage, which we also have options for. But if your app does not tolerate being restarted easily, reserve VMs are a great choice for you. And all of these tie into reserve VMs. Cool. Let's continue down the left here. We're actually getting through this pretty well. My app is entirely client-side code. We've talked about this. If your app is running on the client, that can actually be some pretty cool stuff, right? You could have some pretty neat visualizations. I've actually shared a few. It can be deployed on GitHub pages. It can be deployed on Cloudflare pages. It's a static site. Use static deployments. Really fast, really cheap, really simple, easy solution there. Okay, let's get to the fun one. My app is a mix of client-side and server-side code. For example, you have a front end, you have a back end. You actually have options. Dog. What's up, dog? So the easy solution, if you don't care, run it as a mono-REPL reserve VM. What do I mean when I say mono-REPL? Stuff all that jazz in one REPL and just run it. We're just going to spin up 2 services at the same time. You have to play around with this a bit. I have a tutorial actually on how to do this. So rather than just taking my word for it, go watch the tutorial, which I'll link in the description below, and just deploy it as a single REPL. That's a simple solution. If your app is like a Next app that just kind of has those services baked in, it's actually really straightforward. It only requires one command. Now, the more complex or more advanced solution would be to spin up 2 REPLs and have them talk to each other. For example, say you have a server. You could build out a REPL that's a server, deploy it. Now you have a REPL that's a server. It's listening on some port at some address. The cool thing about development environments, right, is because a development environment is exposed to the web, while you're developing, you just use that development environment as the server, basically, and you can develop live both the server and the front end. It's kind of neat. And you deploy that server, and then you have your front end, and you deploy the front end separately. Advantages here? Well, you could basically segment the parts that you're getting billed for. So maybe I only want to be billed for this like reserve VM, and then I want to offload the traffic, like all the people visiting my app, like most of it's client side. So we want their client to handle most of the workload. And that way I'm not paying for it. But then when they make calls to the server, when they're hitting the API, we want to return data dynamically. I have a tutorial on how to do that. I have a tutorial on how to sort of deploy a static front end with a dynamic back end, thus reducing the cost, offloading most of the work to the client, saving you money, maybe a little bit more efficient, a different setup, slightly more complicated. That's kind of the gist of it. But that's my decision tree. I'm going to make this available to you. I'm going to put this in our documentation. Hopefully that kind of helps you decide how you go about choosing what type of deployment you want to share with the world. Hopefully this video has helped you understand the different types of deployments on Replit and when you'd use each type. Again, I'm Matt with Replit. This has been an introduction to the types of deployments we have and all of our options for taking your idea and putting it live on the internet. But until next time, peace.